So yeah, like I was saying, I'm not really sure what happened, but I will finish this up now. So yeah, weird, the recording just, or the Zoom just stopped. So I'll just finish this up. I'll leave off where we were, which was at this line here. Yeah, person C dot print major, okay? The important thing here is that person is a person, right? So at compile time, let's check compile time. C is an object, but notice we cast it to a person. So that's not a problem, right? It's a person now. But when we do person.print major, well, okay, we go into the person class, and person does not have a I'm recording, right? I think. Yeah, I'm recording. Just want to make sure. Okay, yeah. But person doesn't have a print major method. It doesn't even have one. So this won't work. It's not gonna even manage to compile, because even though you were able to successfully cast C to a person, because person doesn't even have the print major method, it's gonna fail because the compiler is gonna be like, oh, here we have a person and we're trying to use a method that a person doesn't have access to. So it's not gonna compile. So what about the next one? So the next one is one here. What if we instead casted it to a student? We can do that, right? Because a C at runtime is a student. So at compile time, let's see, we cast, it would be an object, we cast it to a student, okay? And then at runtime, so like this is fine, right? Because at compile time, if C is a student has a print major method. So this is completely fine, right, at compile time. So now we check runtime. At runtime, C is a student. And not only that, we're actually able to cast C to a student. This is okay because at runtime, C is a student. So we're actually able to cast it. Like up here, we weren't able to cast it, remember? At this line, because A wasn't actually a student. It was only actually a person. But here, C actually is a student. So we're actually able to do this, right? And it's a student at runtime. So when we actually print the major, it prints computer science. So this is okay. How about the last line? Well, is this okay? Does it work? No, it doesn't work, right? Because we have to go from right to left. We check, is a person a student? It's not. It's the other way around. A student is a person. So we can't have this. This is no good. It doesn't compile. Okay. So, all right, let's go to the searching and sorting. This is the last thing, and then I'll be done. So if we're given this array, A, right, and a target value of 7, how many comparisons do you have to make to figure out if it's found or not? Okay, well, here's the way we do it, right? For linear search, let's do linear search. Okay, so for linear search, we have 12, 13, 50, 90, 100, right? So we have to go through one by one, right? Because that's what linear search is. You check every element one by one. So we check 12 first. Okay, so is 12 7? No, so it's not. And how many times how many different, let's keep track of how many we've checked so far. Let's keep a count, right? So here, count is 1, right? Because we've checked one position and it wasn't there. Check position 2. So now count is 2. Okay, now let's see. The next one, well, it's not there either. So now count is 3, right? This third time. And then count is 4 because again, it's not there. We have 4. And then again, right, we check, and now 5. We checked 5 times and we never found it. So for linear search, we know we have 5. Okay. Let's do binary search. Let's see how many we have for binary search. Okay. So for binary search, so remember, binary search is mid equals floor of start plus n divided by 2. So in this case, the start position is 0 and the end position is 4. Well, 4 plus 0 divided by 2, the floor of that is 2, right? Because we have 4 plus 0 is 4. Divided by 2 is 2. And the floor of 2 is 2 because it's an integer. Okay, so we know we have to start at position 2. So what's position 2 in our array? Well, 0, 1, 2. This is position 2. So we check here. And what we have to do is we have to say, okay, is 50 greater than 7, less than 7, or equal to 7? If it were equal to, we'd be done, but it's not equal, right? So we know that 7 is less than 50. So we know that because the array is sorted, we don't have to worry anything on the right side. Like it can't be greater than 50, and it can't be equal to 50. It has to be on the left of 50, right? Because everything to the right of 50 is larger than 50. And we already know 50 is too large. So anything larger than 50 is also too large. So we can just like cross out all of that. So now our largest, our end, we know the range we have to check in is our end, because now we know position 2 is too large. So now we need to only worry about our end being 1. So originally end was 4, right? And start was 0. But then we checked the middle position, which was 2, and we knew that it was too large. So now we can set our end to 2 minus 1, which is 1. So now our end is 1 and our start is 0. So we again do this and say, okay. We say, okay, 0 plus 1 divided by 2. And the floor of that is 0, right? Because 1 over 2 is a half, and then we take the floor of it. That's just like, floor just means basically like integer division in Java. So that's just 0, because 1 divided by 2 would be 0 remainder 1. But, well, that's just 0, because we don't want remainders. So we check at position 0. Okay. And at position 0, we have to say, okay, is 7 less than 12? Is 7 greater than 12, or is 7 equal to 12? If 7 is equal to 12, I mean, we're done, right? If 7 equals 12, we're done, right? Because we can just say, oh, it's at position 0. It's not that, though. We have to say, okay, now what if 7 is greater than 12? Well, 7 is greater than 12, we have to check somewhere to the right of 12, but to the left of 50, right? So we would change if like, for example, instead of 12, it was like 1, then we know we'd have to check to the right of 1. So then we'd set our start to be our midpoint plus 1, right? But that's not the case, because 7 is not greater than 12. It's less than 12. So in this case, we have to set our end to our midpoint. Our midpoint is 0 right now. So we have to set our mid to 0 minus 1, so negative 1. Well, it's negative 1. So now our end is less than our start. Well, that's not possible. That must mean that 7 doesn't exist in the array. So we know that 7 doesn't exist in the array. We figured that out after 2 checks. So now that was only 2 checks. So the answer is 5 and 2. Okay. So that's how we do searching and sorting for binary search. Let's see if there's anything else that I didn't go over. So it's almost everything. Let's make sure. Oh yeah. Okay, let's go. So for software engineering, one thing we didn't go over is ethics are often recognized, can be codified. And that's, yeah, that's good, right? But then, so actually, let's just go. This is true, right? Ethics are often recognized and can be codified. Like that's general thing we can say. They tend to be personal, but that's not really true because they tend to be shared in nature. Are they based on legality? No, like they're things that we kind of have to figure out for ourselves. So that's false. They're based on moral principles. Yeah, of course, right? That's what ethics are. And they're a branch of philosophy. I mean, yes, technically, yes. Okay. I just want to talk really quickly about this. So I know we talked about it earlier, but I said I want to go over it a little more later. So, right, export's not a thing. Update's not really a thing. So we have like pull, push, commit. So commit is when you like change what's on your local repository. You make a change, you commit, right? And it, like you're still on your local, just like basically updates what's on your local. A push changes the remote. So we have a remote thing over there and a local thing here, and a push changes the remote based on what's in our local. A pull changes our local based on what's in the remote. And clone, clone is when you take the very first time, like I guess I said this earlier, but clone is like the first time when you want to make a copy of what's on the remote and on your own computer. Yep. Cool. Yeah. Okay, and this was like just one more array question I wanted to go over because I thought it was really fun. If you guys want, you can try and figure out what all of these refer to. I mean, okay, I'll give you a hint on this one. This one, Shark Family, kind of refers to this up here. So, but But the rest of them, like, I don't know, if you want to have fun with it, just try and figure out like what champs are. What are these champs in? And like, who are these people? What are they all known for? Like, there's something similar they're all known for. That like you'll hear about a bunch of them eventually, I'm sure. And same with these other people. Who are they? What are they known for? Like, what field? And what fields are these people known for? Just fun. But anyway, well, I guess I'll say that at the end of the problem. But okay, if we make a new array, cool stuff, and we say, okay, it's a new array with 4 rows. We don't have specified columns yet, but that's okay. We don't have to. We just have to specify rows at first. So we just say, okay, we have 4 rows. We don't know how long they are. 0, 1, 2, 3. Right? Now, cool stuff 0 is other people. So we have at 0, like the one at 0 points to this. The one at 1 points to that. I'm just going to redraw it just because it's easier to write. Like cool stuff, row 0 is this, row 1 is that, row 2 is that, and row 3 is that. And then we set people sub 0 to Turing, right? So that means we're setting carp, we're changing it to Turing. And then we say, okay. Cool stuff sub 2 is equal to cool stuff sub 3. So what that's doing is it's saying, okay, whatever 2 points to is now going to point to the same thing that 3 points to. So we're going to change this reference to point instead of there to here, right? To whatever 3 points to. So let me change cool stuff 2-1 to bool. Well, what is column 1 of row 2? Column or row 2 now still points the same thing as 3 now. So now we change Knuth to bool. Right? And then we print arrays.toString cool stuff 3. It's going to print with the change both from Turing and bool. So if we actually look at what that looks like, it's going to look like this: Turing, bool, von Neumann, Lovelace, Gödel, and Koch. And yeah, and so if you guys are curious, this refers to famous mathematicians. This is all world chess champions who were not ever from or who never played for the Soviet Union or Russia. I don't know, I like chess. And this one is like famous computer scientists. These are also famous computer scientists. And yeah, it's like Stephen Cook. Like, yeah, so like just a bunch of like famous computer scientists and stuff. So yeah, fun times. But anyway, yeah, the point is just this mostly. This is what's okay. So I'll put the slides up. I'm sorry again, the video stopped. That wasn't my intention. I don't know what happened, but I'll put it up anyway. I think that's everything I wanted to go over. Good luck on the exam. You guys are going to do great. And yeah.